Hello, welcome. Let us discuss about typecasting in Java. There are mainly two types of typecasting in Java. One is implicit and another one is explicit. Let us discuss them in detail along with practicals. Implicit typecasting means automatic conversion from smaller to larger data type. When you convert smaller to larger data type, there is no data loss. And explicit typecasting is it's reverse, that is manual conversion from larger to smaller data types, and there is a possibility of data loss here based on the data that we provide. Implicit casting is also called widening and explicit casting is also called narrowing. Now let us understand supported implicit conversion, that is smaller data type to larger data type. Byte is smaller data type, here double is larger data type. It supports from smaller to larger data type, that is called implicit type conversion. Here if you look at the size, byte is 1 byte, short is 2 byte, int is 4 byte, long is 8 byte. Here is the one exception where you can convert a long, which is a larger data type, to smaller. This is one feature that is provided by Java because Java prioritizes range over the precision. The implicit conversion or typecasting is generally from lower or a smaller data type to larger data type. But here is the one exception where long can be converted to float. This is the feature provided by Java because Java prioritizes range over the precision. Another supported typecasting can be, you can convert the char is 2 bytes to integer. When you convert char to int, it will provide the ASCII value of the character. We will look into that practically. And again you will convert to larger data type, long, then again it is supporting float here. Here there is a one exception, that is you can convert a long to float. Technically long is a larger data type with 8 byte, but float is 4. But range wise, float can represent the larger range, but long can represent the more precision. See, again you can convert the float to double. So Java prioritizes the range over the precision. That is why here you can convert a float to double, that is a smaller to larger. Here Java prioritizes the range over the precision. That is why here float can be converted to double. That is the only one exception. Otherwise all smaller data type getting converted to larger data type here in the implicit conversion. Explicit conversion or explicit typecasting, where larger data type is converted into smaller data type. Here there is a possibility of data loss. Here you can see larger data type. This is the only exception. Here 8 byte, 4 byte, 8 byte, 4 byte, short is 2 bytes and 1 byte is 1 byte. This is the supported explicit conversion or explicit typecasting. Shortly we will look into it practically as well. Another explicit typecasting is you can convert a double to float, to long, then to integer, then to character. We will look into this practically now. Let me open the IntelliJ IDE and let us practically see how it works. So I have opened the IntelliJ IDE and the project that we have created, and I will create one class here. I will call it as implicit conversion, and here I can create a main function inside the class, public static void main string args. I need to change it to square bracket here. Okay, as we have discussed, supported implicit conversions are these two. One is byte to short to int to long to float to double, and you can also directly convert from byte to double. That is also allowed. We have discussed two different implicit conversions that are allowed. Here you can convert byte to short to int to long to float to double, right? Also you can directly convert as well, byte to double or byte to float, right? That is also allowed. So let us discuss this practically. I will declare now byte b equal to 10. If I want to convert this byte to directly double d equal to b. If I print this statement now, system dot out dot println byte b equal to plus b and system dot out dot println double d equal to plus d. It will print just 10 and this will print 10.0 because we have converted this to double. Let us run and verify this. You can see here byte is just printing 10 here. Here double, you can see 10.0, it got converted to double. So you can directly convert as well, but we will see now how you can convert a byte to short. I will comment this. So I will convert this byte to short now. Short S equal to B, that is byte. And again this short can be converted to int as well. Int I equal to S. Automatically it will get converted. Similarly, you can convert the integer to long. Long L equal to I. And this long you can again here convert to float. FLOAT, float F equal to L. And this float can be converted to double. Double D equal to F. Now let us print each of these variable values. Byte B, so short S. Short S. We will print the value of S. So let us run and verify how it prints these values. So you can see it's all automatically converted. Here float and double will provide the decimal values, meaning all will provide only the full number. Here float and double will provide the decimal value as well. Another conversion is you can convert the character as well here, right? For example, char C equal to, I can provide capital A. ASCII value of capital A is 65. If I convert int, let us say I1 equal to A. If I print this now, system.out.println, I will print this separation line here. I can print here system.out.println char C equal to value of C. And when you convert this C to int, then it will display the ASCII value of A. Let us print that now. ASCII value system.out.println I1 equal to I1. Value of I1 should be 65, which is a ASCII value of capital A. Let me run this. There is some error. Let us see what is the error. Class variable A. Okay, sorry, here character C, I need to assign C here. There is variable name is C, right? So I'll run this now. So you can see character C, value of C will, when you convert it to integer, it will display 65. If you change it to small a, this value will also change, because ASCII value of small a is different from ASCII value of capital A. Here small a value is with C, and C again we are converting to integer here, I1. So let me run this now. You can see 97 is the value, which is a ASCII value of A. Now similarly, you can convert this integer to float, long, double as well. You can convert the, for example now, convert integer to long. Long L1 equal to I1. Similarly, you can convert to float. Float F1 equal to L1. Also, you can convert this float to double. Double D1 equal to F1. Now you can print these values. System.out.println long L1 equal to plus L1. Let me run this now. First it is a character, then converted to integer, then it's converted to long, then it's converted to float and double. So this is the implicit conversion. It means you just assign a value of smaller data type to larger data type. It will automatically get converted. That is implicit conversion. Smaller data type to larger data type conversion. Now let us look into explicit conversion or explicit typecasting. Let me create one more class here. New Java class. Explicit conversion. I will create a main method here. Public static void main string args. So main method is created. Earlier we have discussed two different supported explicit conversions. That is, you can convert from double to float to long to int to short to byte. You can also convert directly to double to byte as well. Let us discuss that practically now. Firstly, I will declare the double D equal to 10.11112222 33334444. Then I will convert this to float, FLOAT, float F equal to D. It will provide an error if you just assign like this, because it is not supporting the implicit conversion. You need to explicitly convert it. For that, you need to provide here FLOAT, float. This gets explicitly converted to float. Similarly, you can convert now float to long. Long L equal to F. So you need to provide here long, explicitly convert it to long. Similarly, you convert to int I, right, equal to L. So you need to explicitly convert it to integer, int. Similarly, short S equal to I. So you need to convert it to short, and then to byte b equal to s. So you convert it to byte explicitly. So let us print these values. System dot out dot println double d equal to plus d. Sorry, here it should be double d equal to plus d. You can print the float f. System dot out dot println float f equal to plus f. If you observe now these two outputs, you will find the difference of data loss. For example, if I run now, you can see double d value is this much long. When it is converted to float, there is a loss of data. When the double is converted to float, you can see there is a loss of data. This much data is lost here because double will represent the higher precision, that is more number of decimal values, but float will not represent that many decimal values. That is why when the larger data type is converted to smaller data type, there is a possibility of data loss. So let us print other values as well now. So let us run this. So you can see here to here there is a data loss. From here onwards, here again long, when float is converted to long, this decimal values got removed because long will not represent any decimal values. Again thereafter same value is retained, right? If it is a larger value, for example instead of 10 it may be 10,000, then there might be data loss here as well. For example, if I say 10 2 2 2 2 3 3 3 3 4 4 4 4, right? If I run this now, you can see here there is a data loss. It becomes 0 here because it is not able to hold the larger value. So in this way, when you convert the larger data type to smaller data type, there can be a data loss depending on the value provided. 1022 I have provided here, just 2 is displayed, you can see byte, right? So there is a data loss. So similarly, another supported explicit conversion is double to float to into char. So you can convert here as well integer to character. For example, let's say this is a int, right? So int I we already have. This integer we have already converted this double to float to long to int. Double to float to long to int. So here you can convert this to character. So for example, char c equal to, I can assign an integer value, right? For example, char explicitly converted. So if I print the system dot out dot println char c, so it should, based on the ASCII value, it should display the character. Let us see. So this character is displayed. You can see char c equal to this kind of symbol. Okay, yeah, I will change this value. For example, I will change it to, let us say, 65. Now this character should be capital A. We know ASCII value of capital A is 65, right? Let us run this. See, you can see now A is displayed, capital A. So it is getting converted to character based on the ASCII value that is provided for by integer, right? So in this way you can do the explicit conversion. You need to remember there can be data loss when you convert the larger data type to smaller data type based on the value that we have. So we have learned about type casting. This is also called type casting. Remember, explicit type casting, and here this is also called implicit type casting. So we have learned implicit and explicit conversion or a type casting in Java. Thank you for watching.